Hi, I'm Cheryl Leach. In this problem, we're going to be sketching the graph of a function f that has a list of characteristics. Well, let's take a look what these characteristics are and what they tell us about the graph of our function. The first one tells us that f of -2 is the same thing as f of 0 and that they both equal 0. Well, that tells me that there are x-intercepts at the point x equals -2 and x equals 0. So x-intercepts at x equals -2 and x equals 0. That's because the y-coordinate is 0. Let's look at our next characteristic. It tells me that the derivative is greater than 0 as long as x is less than -1. Well, I know that when a derivative is greater than 0, that means the function is increasing. So my function is increasing on the interval from -∞ to -1, because that interval represents all the values less than -1. The next characteristic is similar. It's just that the derivative is negative. When the derivative is negative, that means my function is decreasing. So I'm decreasing on an interval. Well, which interval? Anything between -1 and 0. So from -1 to 0, I'm going to be decreasing. Okay. The fourth characteristic is again very similar. I want to know when the derivative is positive, which means it's increasing again. So I'm increasing, and this time I'm increasing when the x value is greater than 0. So that will be the interval from 0 to infinity. Now let's take a look at that last criteria. This one's a little different. This time I know that the derivative when x equals -1 and when x equals 0 both equal 0. Well, if a derivative is equal to 0, that means the tangent line is horizontal. So we have a horizontal tangent line. And what else do we know? Well, that's going to be the location of critical numbers. And so it's a possibility that I'll have a change from increasing to decreasing or vice versa. And I can actually see what's happening from the information above. At x equals -1, I notice that I change from increasing to decreasing. So I'm increasing and then decreasing. That gives me a relative max. And then at x equals 0, I notice that I'm decreasing and then I change to increasing. Decreasing, changing to increasing. That gives me a relative min. So I know I have relative extreme at those 2 points, and the tangent line is horizontal, so it'll be a nice smooth turn with a horizontal tangent. Well, let's see if I can translate all of this information into a graph. Right? So the first thing I notice is that I have x-intercepts at -2 and at 0. So I'll put those in. I also know that I'm going to have a relative maximum at -1. Now, it doesn't tell me what that relative maximum is. I can really put it in anywhere I like. So I'll put it right there. And a relative minimum when x equals 0. That point's already on my graph. Well, let's see what happens. I need to be increasing until I hit this relative maximum. So I'll be increasing, and then I'm going to have a nice smooth turn, and then I'll start decreasing until I hit 0, and then again with a nice smooth turn, I begin increasing again. So that's one possibility. But like some of the other problems we've been working on, that's not the only way that I could graph the function. Let's see if I can come up with another way. Well, the one piece that was really kind of arbitrary in all this was where I put the maximum value. Let's say instead of putting it at the point -1, +1, I have to locate it at -1, but let's say that relative maximum is 2. I still have the same x-intercepts and minimum, and I still need to be increasing till I hit this point, decreasing until I hit 0, 0, and then increasing again. So maybe it'll look something like this. This also fits all of my criteria. See if you can come up with another graph that fits my criteria. I hope this was helpful. Thanks.